This is for Year 12 Specialists. It comes out of 2C question number 17. So we have this object. I know that O to A is 3J, O to C is minus I plus J plus 2K, and O to D is 2I minus J. Show that the lines DB and CE bisect each other and find the acute angle between them. Okay, since I need DB and CE, I'd like to find expressions for them. So DB, so going from D to B, is the same as going from D to O plus O to C plus C to B. And C to B is the same as O to A, so that's D to O plus O to C plus O to A, which equals, D to O is that backwards, minus 2I plus J, OC is minus I plus J plus 2K, and OA is plus 3J. So looking at the I's, minus 3I. Looking at the J's, 1 plus 2 plus 3 is plus 5J. And looking at the K's, plus 2K. That's dB. And while I'm there, the magnitude of dB will be the square root of 9 plus 25 plus 4, the square root of 38. And I also need CE. So CE will give me C to O plus O to D plus D to E, C to O, O to D, D to E gives me C to E, which is C to O plus O to D. D to E is the same as O to A. And that's going to be C to O, which is that backwards, I minus J minus 2K, O to D plus 2I minus J, O to A plus 3J. Looking at the I's, 1 plus 2 is 3 in the I. Looking at the J's, minus J minus 2J plus 3J is plus J. And looking at the K's, minus 2K. And while I'm there, the magnitude of CE will be the square root of 9 plus 1 plus 4, which is the square root of 14. So I've got this is dB and this is CE. Okay, how do I prove, or no, sorry, how do I show that they bisect each other? So if I was going to look and see what's happening here, I've got D to B, which is the diagonal that runs across there. And I've got C to E, which is the diagonal that runs across there. And they're going to intersect at a point. I'll call that point M. And if they intersect each other, if they bisect each other, then D to M is going to equal, so D to M is going to equal some scalar times D to B. Or I could say that D to M equals M to B. And C to M should equal M to E. Or I could say that C to M is some factor of C to E. Okay, now if they are bisectors, both P and Q are equal to a half, but I can't use that. So what I'd like to do is I would like to get a chain of vectors, and the way I'd like to do my chain of vectors is I go O to M, going from O to M. And one way I'm going to do it is seeing it's O to M is the same as O to C plus C to M, which is O to C plus C to M is Q times C to E. Which is going to equal O to C, which is minus I plus J plus 2K plus Q times C to E. And C to E, if I move across, is 3I plus J minus 2K, which is going to be, in the I's, I've got 3Q minus 1, and in the J's I've got 1 plus Q, and in the K's I've got 2 minus 2Q. And I also know that OM, if I go the other way and I include D, is O to D plus D to M, which is O to D plus D to M is Q, so P times D to B. Where P is some factor along here. So O to D is 2I minus J plus P times O to B. D to B is minus 3I plus 5J plus 2K. And in relation to the I's, it's 2 minus 3P. And in relation to the J's, it's going to be negative 1 plus 5P, so 5P minus 1. And in relation to the K's, it's going to be 2P. Since O to M and O to M equal each other, therefore 3Q minus 1 equals 2 minus 3P. That's equation number 1. Reconciling the J's, 1 plus Q equals 5P minus 1, reconciling across the 2's, and 2 minus 2Q equals 2P can be my third equation. Rearranging this, I get 3Q, move that over, plus 3P, move the 1 over, equals 3, or Q plus P equals 1. And rearranging this one, I get, I'll move that over to there, so I get 2 equals 5P minus Q. And since I have two equations with two unknowns, I can add this equation to this equation to get 2 equals 5P minus Q and 1 equals P plus Q. Add them together, 3 equals 6P, P equals a half, and because P plus Q equals 1, Q equals a half, and because they're both equal to a half, therefore the lines bisect each other. And the last bit of the question asks about finding the acute angle between them. Then I know that to find the acute angle between them, that I can move all the way down here, dB dot CE will equal minus 3 times 3 is minus 9, plus 5 times 1 is plus 5, plus 2 times minus 2 is minus 4, and that's going to be minus 8. And I know that the cos of the angle will be dB dot CE over the magnitude of dB times the magnitude of CE, and that's going to equal negative 8 on top of the square root of 38 times 14, which means the angle is the inverse cosine of minus 8 on top of the square root of 38 times 14, and on my calculator that gives me theta equaling 110, and when I minus that from 180, it's going to give me 69.705 or 69.71 degrees. Okay, that's the question.